गुड मॉर्निंग स्टूडेंट्स। आज का हमारा टॉपिक है रिप्रेजेंटेशन ऑफ एन इलेक्ट्रोकेमिकल सेल। तो इलेक्ट्रोकेमिकल सेल जैसा हमने पिछले वीडियोस में किया है, इलेक्ट्रोकेमिकल सेल में हम केमिकल रिएक्शन, इनडायरेक्ट केमिकल रिएक्शन करवाते हैं, जिसमें एक हाफ सेल में हम ऑक्सीडेशन करवाते हैं और दूसरे हाफ सेल में हम रिडक्शन करवाते हैं, और एज अ रिजल्ट इलेक्ट्रॉन्स प्रोड्यूस होते हैं, वो वायर के थ्रू मूव करते हैं और इलेक्ट्रिक करंट प्रोड्यूस होता है। अब जैसा हम केमिस्ट्री में पहले भी करते आए हैं कि इतना बड़ा सेल बार बार ड्रॉ करने में देयर इज अ लॉट ऑफ टाइम वेस्टेज, तो वी हैव डिवाइज्ड अ मेथड ऑफ writing the whole structure in a short form. This writing a cell, the method of writing the cell is called cell representation or cell notation. First we follow some conventions. So the conventions are that the galvanic cell will be represented by writing the anode always on the left side and cathode on the right side. And while writing the anode, the metal is written first, followed by semicolon, and then we write the name of the electrolyte into which this metal is dipped, or we can simply write the ions into which this metal is dipped. To give further information, we can also give the concentration of the electrolyte in brackets. For example, for zinc electrode, if it is acting as anode, zinc semicolon, then zinc ions and its concentration in brackets. There is another way of writing that instead of placing a semicolon, we can also put a vertical line in place of metal and its ions. Just to repeat, that anode is represented by writing metal first and then its ions. On the other hand, cathode is represented by writing the ions first, then a vertical line, and then the metal, or ions and semicolon and the metal. You can also write the concentration of the ions by writing it in brackets. The salt bridge is indicated by putting two vertical lines between the anode and the cathode. Overall method is writing the metal electrode, then vertical line, metal ions, then salt bridge, then metal ions of the reduction half cell, and vertical line and metal of the cathode. We will repeat that we move from left to right via the salt bridge. First metal, then ions, then salt bridge, then ions, and then metal. The complete formulation of a cell, which is known as cell notation, is represented as follows. You must also know the terms associated, like the electrode where electrons are lost is called anode and it is given negative charge, and the electrode which takes the electrons is called cathode and is given the positive charge. So we have represented this in our cell notation. First we will write the anode, then this anode is assigned the negative pole, then we write down the ions, vertical line, then ions into which the anode is dipped, we write its concentration in brackets. Now this is the electrode where oxidation occurs. Then we write down double lines for salt bridge. Then the ions over here, for example copper ions with their concentration, and then we put this metal copper. This is assigned the positive charge. Just in case you get confused ki which electrode is to be kept to which side, just remember the alphabetical order. Like in alphabets, A appears first and then B and then C. So whatever is placed, what appears first is placed first. For example, left and right. L comes first, L, M, N, O, P, Q, R. R comes afterwards. So L will be towards the left. We have anode because A comes first, C comes afterwards. At anode, oxidation occurs because out of oxidation and reduction, O comes first. So oxidation will be written on the left side. And out of negative and positive, N comes first, P afterwards, so negative. So I'll just repeat. Anode towards the left, oxidation occurs at the left pole is called the negative pole. Similarly, cathode is right, reduction occurs in the right side, and positive pole is towards the right side. So if you have understood how a cell can be represented, then let us take a few examples. You must know that from a reaction you can understand which of the substance will be anode and which will be cathode. The substance which is giving electrons will be anode, and the substance which is taking electrons will be cathode. In the overall cell reaction also, for example, in a copper silver nitrate cell, the overall cell reaction is copper plus silver ions forms copper ions plus silver. So copper is giving electrons to form copper ions. So this is anode. Silver ion is taking electrons to form silver. So this is cathode. So copper gives electrons to form copper ions. This is oxidation half cell. Silver ions take electron to form silver. This is reduction half reaction. Overall reaction is copper plus silver ions will form copper ions plus silver, and cell may be represented as anode, anode ions, salt bridge, cathode ions, cathode, copper solid, copper ions, aqueous. Here you may in bracket put the concentration, then salt bridge, then silver ions. This is aqueous, and you may write the concentration, and silver solid, vertical line between them. Similarly, nickel silver nitrate, nickel gives electrons, silver takes them. So nickel is anode. So left hand side we write nickel, then vertical line, nickel ions, salt bridge, silver ions, silver, vertical line. Similarly, for zinc HCl cell, zinc gives electrons, hydrogen receives to form hydrogen gas. Overall reaction is zinc plus hydrogen ions will form zinc ions plus hydrogen. Anode will be kept to the left side, first metal, then ions, then salt bridge, then ions, and then the electrode. Now hydrogen is a gas. So actual electrode is an inert electrode which is put in an atmosphere of hydrogen gas. So we have to write in bracket platinum also for hydrogen electrode. So these are some examples of cell representation. If you like my video, please do subscribe, share, press the like button, and also press the bell button to know more notifications.